you can kind of see these little pale violet crystals. Now, we're dissolving just a little water. And as it dissolves here, what we're noticing is it's not pale violet anymore. The water came in bound to the metal and changed the energy levels just a little. As a result, it's now yellow. We can change this some more. This, we're going to move, and we need a little more volume here, so I'm going to transfer this all to a bigger beaker. This is a compound called ethylene glycol. You can see the structure of it up here. It will also bind to the ion. So I'm going to add some of that. I want to have lots of ethylene glycol so I can get water off your ethylene glycol on. So I'm adding extra ethylene glycol. When we add it, you saw it was clear liquid. We add it, and note, now we've got this burnt orange. A little darker, a little different color. The energy level shifted again. But we do a little more than that. This is thiocyanate, sodium thiocyanate. This will bind iron. In fact, this is famed for binding iron. Still clear solution. It's got no color of its own. It does an interesting thing when it can combine with iron 3+. You mix iron 3+ and thiocyanate. It looks black. It actually isn't. Let me tip the edge a little bit. It's a deep crimson red. Distinctive color. Many tests, chemical tests for iron, are based on this. Now, there are other ways we get color. Could you advance to the next slide, Julian? That we can get color naturally. There are some critters down in the deep fish. There's not much light down there for them, and so they have a tendency to produce their own. Got pictures of a few of them up there on the screen. They do this by something called bioluminescence. There's a little video of it here. They have inside them a compound called luciferin. That reacts with oxygen. There's luciferase, is an enzyme that catalyzes and helps the reaction occur. Now, when those react, that puts energy into a compound in that similar, it's not the same energy levels, but it's the same principle. You're promoting up from one energy level to another energy level, and to get rid of the excess energy, the creature will give off light, and often it's blue. And so, you got high energy reaction here. It becomes the critter itself is a little too high energy. It needs to release some energy. It gives it off this blue light, and it glows. Alas, I have no glow-in-the-dark fish with me. Tried to catch them, fish couldn't get any. But I have something called luminol, which is kind of similar. It doesn't react with oxygen. It will react with hydrogen peroxide. If you get ready to get the lights for me. I'm going to add some hydrogen peroxide here. And okay, go the light. And we have our own little, may be a glow-in-the-dark fish, but it's kind of glow-in-the-dark chemistry. Now, being not terribly spry, I decided it probably makes sense for Julian to be the one who does this. Ready? Go. The mints in this case, the Diet Coke has the CO2 dissolved in it. The mints provided the nucleation sites, and that was the result. If we can take the air in these balloons Charles Law. Make the hair take up less. All you. You give me my poems. How many balloons can we get in this container? Yes, and they said all of them. You're right, all and more. Yes, this is one of the ones that, being negative 300, this is cold enough it will burn you just like fire would burn you. This is one of the experiments. That part you could try at home. Parents, don't sue me. Get your parents' permission. You know, the whole disclaimer they fund the game commercials. But this, do not try at home. And if you're at home and find a source of liquid nitrogen, however, please email me. Now, if we let it warm up, the volume will increase again. And the balloons,
I can't see. Can you put it on the other side?
will return. All right. In some cases, balloons are not really capable of handling the return. We have in these balloons some fuel. This one's got hydrogen. This one has hydrogen and oxygen. When we perform combustion, the product is water. Therefore, the one with hydrogen and oxygen, we would think would be well better set to produce water. Let's find out. You might want to cover your ears. We might want to relight these flames. All right, cover your ears.
Oh, wow.
Now, that was the smaller. That was the just hydrogen. Let's see what happens with hydrogen and oxygen. Cover your ears. Going to be the hydrogen or even hydrogen and oxygen. Sugar is a good fuel source. And so, if you were to put sugar in the proper material, for example, hot chromic salt. If you were to stick this in a hot, chlorate salt, you can get a fairly spectacular reaction, as demonstrated. That's what's happening in your stomach when you eat gummy bears.